Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. This is third video on kinematics and measurements, past paper questions from Cambridge AS Physics. If you didn't watch part 1 and part 2, you can go back to the channel and search for kinematics and measurements part 1 and part 2 to fully understand kinematics and measurements. So here is our first question. So let's try to understand what is given to us and what we need to find. So this question is about experiment to find the acceleration of free fall of a body from rest. So what exactly it means? The free fall simply means that we can ignore a resistance, and from rest simply means that the initial velocity is equal to 0. So or we can also say that u is equal to 0. So this is what rest is telling us. So what we need to find out, we need to find the measurements we need to calculate acceleration. So let's first of all try to set up this experiment. How we can find value of g means acceleration, how we can find. So here is ground, as you can see here. Let's say we drop this ball from rest, means initial velocity is equal to 0, and finally the ball will hit the ground at this point. So one way to do this experiment is we can find this height, mean the vertical displacement covered by this ball. I can say this is equal to h. So in this case, as we have h, we have u, so we can use kinematic equation, because in this case acceleration is uniform, so it means we can use kinematic equations. So s is equal to ut plus 1/2 at square. So in this case s is equal to h, we can say s is equal to h. As u is equal to 0, we can simplify, so we will get this is 1/2 at square. So we need to find a, so we can rearrange this equation. We can simply say this will be equal to 2h over t square. So with the help of this equation, we can find acceleration of free fall. So 1h is the height of fall and t is the time taken. So now let's go back to given options and see which one is the best possible answer. For this question, as you can see here, for option A, it is given to us height of fall and time of fall. So this is correct answer. Okay, the second one, height is okay, but we don't need weight actually. The mass we don't need for this one, so this is also not possible answer. The mass we don't need, so this is also not possible answer. So the answer for this question is A. This question is quite straightforward one. If you read this question, you can see it is given to us that acceleration is uniform and the body is moving in a straight line. In this case, actually is a particle that is moving in a straight line. So uniform acceleration simply means that its acceleration is constant, is not changing with time. So we simply need to identify which graph can represent the motion of the particle. So in order to answer this question, the first thing we have to understand, it is constant. So the acceleration is constant, uniform, sometimes little confusing for some students, so we can also say that it is constant. So constant acceleration simply means that if we have the velocity time graph, let's say we have velocity on y-axis and we have time on x-axis, so the gradient of this one has to be constant. So in this case, the gradient of vt graph is equal to acceleration. Gradient of vt graph is equal to acceleration. If acceleration is constant, so what it means is that gradient has to be constant. If A is constant, gradient also has to be constant. So if we have this understanding, then we can find answer. So if you look at option A, for example, this is distance against time graph. This is simply telling us that object is at rest. So the velocity is 0. So this is not our answer. If we look at B, the B is simply telling us that velocity is constant. If the velocity is constant, it simply means that acceleration is equal to 0. Now, if we look at option C, now we have velocity on y-axis, we have time on x-axis. As we can see, the velocity is increasing at a constant rate, so we can simply say acceleration is constant. Or another way of understanding is that as its gradient is constant, it means acceleration is also constant or uniform. So this is our answer. But if we look at D now, so this is telling us that acceleration is not uniform, it is non-uniform, it is increasing with time. So D is not answer because D is non-uniform. So this is not our answer. So our answer for this question is C. For this question, motion of two bodies, body X and body Y, is shown on velocity time graph. So it means that we need to understand velocity time graph first of all, and then we can find the best possible answer. So as you can see here, so we have velocity on y-axis and the time is given on x-axis. So time is given on x-axis. So which statement is correct, we need to find out. So here, as you can see, option A is about comparison between acceleration of x and y. B is also about acceleration, and the C is about distance, and D is also about distance. So we have to choose the best possible option from these given 4 options. So how we can answer this question? So the best way to answer this question is, first of all, let's have a look at velocity time graph. Let's say we have velocity on y-axis. As you can see here, this is velocity on y-axis, and we have time on x-axis. So let's say if this is a line on velocity time graph, so what is the gradient of this line? It means the gradient of VT graph. I will simply write down the gradient, that is equal to A. So how about area under this line? I mean area of this graph, area under this graph, this one. So we can say area under graph. So we need to find, so that one in this case will be equal to displacement. So in this case, distance and displacement are same, as these two bodies are moving in a straight line. So now let's try to find out area under x. Area under x, for example, we can find out area under x means this is line, actually this is a triangle. We need to find area of triangle. So area of triangle is simply equal to 1/2 times base times height. So the base is 5, height is also 5. So our final answer will be 12.5 meters. The next we also need to find out area under y. So area under y we can also find out, but area under y we have to be clear about this one, because most of the time students, they just get confused with this one. They don't understand which area they need to calculate. So in this case, let me highlight which area we need to calculate. So this is the area what we need to calculate, means this area. This is the area what we need to calculate. So this area is kind of trapezium, but we can also simplify this one. We can divide this into triangle and rectangle. So if you didn't remember the formula for trapezium, so this is, we can divide into triangle, and also we can divide this one into rectangle. So this is rectangle, as you can see here, rectangle. So the area under X is equal to area of rectangle plus area of triangle. Okay, so how we can find area of rectangle? As you can see, this is 2 is here, so 5 is here, so simply we need to multiply 2 by 5. 2 by 5. So we have to find area of triangle now. So you can see, so area of triangle simply is equal to 1 by 2, and the base, actually base is equal to 5, and the height, this is equal to 1. So this is 1. If we simplify this one, our answer again will be equal to 12.5 meters. So it simply means that the distance traveled by X is the same as distance traveled by Y. Okay, so this is one thing we have found. Now let's try to find acceleration of X. Acceleration of X simply means change in Y, delta Y by delta T. This is delta Y, or we can say delta V by delta T, or you can say delta Y by delta X for gradient. So in this case, that is equal to 5 divided by 5 and is equal to 1 meter per second per second. We can also find acceleration of body Y. Again, same formula, delta Y by delta V by delta T. So in this case, you can see the change in V is 1, means the delta V is equal to 1, and time taken is equal to 5. So the acceleration of body Y is equal to 0.2 meters per second per second. So this is, now if you look at these options now, acceleration of X and Y are the same. So that is not true. That is not true. Initial acceleration of Y is greater as, but we can see here Y is smaller. So this is wrong. Distance traveled by X is greater. No, it is not greater. Actually is equal. Equal. So this is also not answer. The distance traveled by X and Y in the 5 seconds period are the same. Distances covered same. So this is our final answer. So this is how we can answer this question. So only the tricky part is that often students, they make mistake with this part. They don't count area of rectangle. So you need to understand, if this is the situation, you have to consider area of triangle and area of rectangle. This question is about projectile motion, and this question is just testing your basic understanding of projectile motion. So let's try to answer this one now. As you can see, in this case, it is given to us a projectile is fired at an angle alpha to the horizontal at a speed u. So this line is horizontal. It simply means that it makes angle alpha with horizontal, and its initial velocity is u. So what we need to answer, we need to find the vertical and horizontal component of its velocity after a time t. And also you can see here it is given to us that a resistance is negligible. So it simply means that in this case, only force acting on projectile is gravity. So simply gravity is only acting, and gravity, we understand, always acts downwards. Always acts downwards. So this is very important piece of information we need to understand. Now let's try to resolve this one first of all into its components. So the first component you can see is horizontal component of this velocity, and also we can resolve into vertical. Means we resolve into two components, vertical and horizontal. So these are the initial velocity components. Mean horizontal component of initial velocity, we can say that will be u cosine of given angle. In this case, angle is alpha, so we can also write down that is u cosine of alpha. And the vertical component of initial velocity will be u sine of given angle, because this is opposite to this angle, that's the reason it is sine. So this is u sine of alpha. Okay, now as we have already discussed that only gravity is acting on this, and as only gravity is acting, it means there is no force along horizontal, so the horizontal component of velocity will not change. So we can also say that horizontal component of velocity stays same. So horizontal component stays same. Stay same means does not change. Stays same. Stay same. Why? Because no force is acting along horizontal. If there is no force, it means that A is equal to 0. Mean there is no resultant force, so velocity component stays same. Now how we can find, so this is one thing we have found. Now next thing, when we fire this ball, it will follow this trajectory somewhat like this. So now let's say if after time t at this point we need to find the velocity, so velocity will be like this at this point. So we can resolve this velocity into two components. We can resolve into horizontal component, and also we can resolve into vertical component. As horizontal component is not changing, so it will stay same, so this horizontal component will be equal to u cosine of alpha. Now we need to find the vertical component, means vv at this point. How we can find that? So for this one we need to look at vertical motion. So we need to look at vertical motion. So for vertical motion, as we can see, the u initial is given, initial vertical velocity is given, uv I can say, that is given, and that is equal to u sine of alpha. This is given. After time t, means the time is given to us, so I can say in this case time is given, the time taken is equal to small t, and a is also given, a is equal to 9, a is equal to g, because there is only one force acting, that is gravity, so it is equal to g, and that is equal to 9.81, as the acceleration is acting down but the initial vertical velocity is acting up. Now what we need to find? We need to find velocity after time t. This is what we need to find. Now as you can see here, the u is given, t is given, a is given. Simply we can use v is equal to u plus at. Now before we plug in values, we need to understand, as the initial velocity, vertical initial velocity is upwards and acceleration is down, so we need to take one direction as positive. As the initial direction of motion is up, we will take up as positive to make our calculation simpler. We can also take down, but it doesn't make big difference. But if we take direction of motion positive, it will make our calculation simpler. So if we took up is positive, this component will be, means the initial velocity will be positive, but the value of a will be negative. So now just plug in values, that's all. So we can say u is positive, so this is u sine of alpha minus g times t. So this is over the vertical component of velocity after time t. So if you look at these options, so this is not possible answer. This is also not possible answer. This is correct, but this is correct. This is also, so vertical component and horizontal component, but this one is wrong. This one is also wrong. So our answer for this question is C. So this is how we can answer. So this is a basic concept about projectile motion, so we have to be quite clear about this. Finally, this is the last question for today's class. As you can see, this question is about vectors. What we need to do with these vectors is we simply need to add these two vectors. So it means we need to add vectors p and minus q. We need to add these two vectors together. So what is given to us? In this case, vector p is given and vector q is given. So how we can add vector p and minus q? So minus q, actually this is called negative vector. So the negative vector simply means that its magnitude is the same, but simply its direction is opposite. Means its magnitude is same, only its direction is opposite. So simply we can draw like this. So this one is over minus q. So this one is minus q, mean this is our negative vector. Now we have one vector p and other vector is minus q. So how we can add these two vectors? Simply if we have this vector minus q here, we can just replace this one. We will not change its direction, we will not change its magnitude. We can change its position. We can move from this point to this point. So move to this point now, as you can see here, move to this point now. So this is our vector minus q. Now you can see here, so it's very easy to add these two vectors now. So we can use head to tail method, head to tail method, head to tail method. Tail method. So this is vector p, this is minus q. We need to add these two vectors. So our resultant vector will start from the tail of first vector to the head of last vector, to the head of last vector. So let me little clean this one so you can see a little more clear. So this will be the resultant vector. This will be the resultant vector. So if you look at given options, so D is the best possible option. If you compare this vector with this one, they are similar. So our answer for this question is D. So this is how we can answer. So simple thing, first thing you need to understand what is meaning of minus q. Mean is a negative vector. Mean you no need to change its magnitude. Simply you need to change its direction. That's all. Then just use head to tail method, and then you can find the resultant vector.